This conference will now be recorded.
We should also learn, like, I have taught you, like, how to get connected to the CloudX lab and how to practice in the CloudX lab with free trial version. That is one thing we had discussed some time back. Okay. Like, I'll upload all the sessions today. I'm waiting for some this thing. But today I'm going to upload all the videos so that you can also go through that, how to connect it to CloudX lab. Maybe if you don't want to purchase it, you can go for a trial version. That would be useful for you. That is one thing. Next thing, and also we need to understand, like, how to work with the Cloudera distribution. We'll download that and we'll see how to create our own virtual machine and how to start working from our local machine itself. If you have that, but for that, the minimum RAM required is 8 GB. That is the limitation. Or if you have that, you can download and can start working. If you don't have, then one thing is we have to upgrade it, or otherwise, at least you can practice with CloudX Lab. These are the two possibilities. Which one you want to choose is your choice. I don't want you to waste your money, but still, if you want to have a better experience, having your own Cloudera distribution in your local machine is recommended. But still, I don't know, right? Your financial limitations, I don't know. So you think about on that lines. So now, as discussed in yesterday's session, when you talk about Hadoop, you know, what Hadoop, it is used to store and process. And yesterday it was very clear for us what is that. For storing we use HDFS. For processing we use MapReduce. I hope you remember that. We started discussing that in yesterday's session. Okay. And there were many versions. Once we finish all this HDFS and part, then I will quickly see the differences between 1x, 2x, and 3x as well. What are the differences between 2x and 3x? That is also there. We'll try to understand that as well. And this is what we are talking in yesterday's session. We are talking about HDFS architecture. So it has the following services. We were talking about these services: name node, secondary name node, job tracker, task tracker, data node. This is what we are talking. Generally, when you talk about it, any Hadoop architecture, it has two things actually. What is that? The storage. If it is storage, how the storage happens, gentlemen. Okay, this is actually our YouTube channel. Before quickly jumping to the discussion, Manohar space learn well space tech. All your videos, both big data, Python. I am also planning to do machine learning as well. So these videos are available in Manohar Space Learn Well Space Tech. Okay, you can go through that. And also we have weekend Python sessions, free sessions. None of our sessions are commercial or we will charge for anything. Not now, even after the completion of course, you don't need to pay any money. There is no commercials involved here. Okay, so that is one thing. Next, let's quickly switching back to this. Hadoop is used to perform storage and process. For storage, obviously it will always use HDFS. For processing, it will use MapReduce. So okay, if I'm talking about Hadoop One-X, okay, this is about Hadoop One-X. In Hadoop One-X, this happens. Reduce. For processing, it uses MapReduce. But for 2x or 3x, storage doesn't change. HDFS is always there. It is not going to change. Hadoop distributed file system. Storage always happens at HDFS. But what changes? The processing changes. Instead of MapReduce, we might get yarn from 2x. That is the difference. But still, there is no change in the storage part. Always the file structure, the storage is done in HDFS in Hadoop. Okay, still, even in our products, we keep using HDFS every day, without which we don't finish our works. Okay, so fine. Now, We have understood that HDFS has all these daemons or threads or processes or services running. Okay, name node, uh, job tracker, and secondary name node master. If you look at that diagram, I can just quickly take a detailed diagram here. Okay, fine. Okay, we can get from some the Google itself. Okay, so the HDFS architecture, you can go through some images. That will be fine for us. We need something where it shows everything for us. Data node, job tracker, task tracker, everything. We'll just try to get such kind of this thing. This is the official diagram, whatever you are seeing here. Even we have downloaded that. This green in colors, these are official. You get from actually Apache website. Okay, this Hadoop official website. I'm just looking for task trackers so that it's easy for explaining for us. I can also draw it. Yesterday we have I have drawn and explained. Okay, this diagram looks good here. See this. Lecture matrix processor. One I got here. So genuine pointer he is saying, okay, this is the one, okay. So save as. Okay, I'm saving it in my machine. Let's open this. So this is actually the required diagram, okay. We can see here now. So this is architecture of your HDFS. And here you can see, I told you yesterday also, this job tracker, this name node, the secondary name node, all these are master nodes. Okay. So master nodes in sense, these are softwares running on, running on some servers. Okay, these are all master nodes. Master nodes means they are physical machines. And name node is a service. It's a software. Secondary name node is a software. Job tracker is a software. Okay. Okay, fine. We have discussed all this yesterday. You can go through the yesterday's video if anybody have any doubts. And if you see, name node is connected to data nodes. If you see carefully the connection, name node will be monitoring data nodes, and job tracker, you can see here, job tracker, look at that line, it is connected to task trackers. And there will be edge node here. Client instance, client acts as the edge node. From edge node, if you submit anything, it will talk to name node first, get the metadata. Then with the help of that metadata, what happens? Job tracker will start running the task trackers. So still, I didn't discuss job tracker and task tracker. I am continuing with that. So now, as I had finished discussing yesterday, name node, data node. Of course, we need to quickly get an idea about secondary name node. We'll talk on that. Okay. So, as discussed yesterday, what is that? Name node, data node takes care of storage. We had discussed it. And then job tracker and task tracker takes care of processing. We have discussed that. These two are part of map reduce. Job tracker and task tracker. These are map reduce services, and name node, data node are HDFS services. Okay. So again, next one. Secondary name node is also part of what is that storage. Okay. And for processing, what do we have? For processing, we have job tracker and task tracker. Okay. now. And I have explained this. What is name node? How name node works? It is used to hold metadata. Okay. And what is metadata means? All the files, blocks information, rack information. That is metadata. I'm just moving to the next topic because already we had a detailed discussion. Data node talks to name node by using what? Heartbeat signals. Okay. For every 3 seconds, you have a heartbeat signal. We have discussed that yesterday. And data node is a slave machine on which data is. Actually, data is stored where? Is it stored in data node or name node? Name node doesn't store data. It stores only metadata. Then where this data is stored? Data is stored in data nodes. Okay, in this diagram, if you look at this diagram, data always stored in data. If you see, it is shown in the form of blocks. You can see small. You can see this chiclets kind of red color small bricks. These are nothing but blocks. Okay. So data is always stored in data nodes, not in name node. But what name node has? Name node has all information about data nodes. Got it right? All the blocks, everything, the block information. I'm moving. And when there is a failure, suppose a data node is dead, actually, it has failed due to some hardware issue or something else. Then what happens? The blocks of this node is moved to other node. We had a discussion on that. Then what else? Write and read mechanisms, nothing to worry about it. We might talk a bit about it later. And then next one, job tracker and task tracker. What is this? Let's talk about it today. Let's move to discussion of once we finish it. Job tracker, task tracker. Let's have a quick idea about it. So job tracker is same as your what is that? Job tracker. Next. It is also what is that? Is a master service which takes care of what is that? All slave service, master service. Okay, what it does? Which monitors and assigns work to task trackers. Actually, these tasks are executed by whom? Tasks are executed by task tracker, not job tracker. Job tracker is like a supervisor which monitors all these task trackers. I got it right? Execution part is taken care by these two. And here job tracker is a master which monitors all the task trackers. Okay, as I told you yesterday, suppose I want to execute a query like this, select star from EMP. That is my query. Just a quick simple analysis. Star from EMP. Okay, where salary greater than or equal to some 50,000. When I say this, okay, I 5 lakhs are also fine. When I just try to execute this run, when I try to execute this query on the cluster like this, first what happens? Selection is a execution. It's a processing. It's not storing. Okay, suppose if I say this command, then it is a storage. I'll just show you here. I'll show the clear difference to you. When I say something like this, is that like HDFS, DFS, you can use Hadoop FS command as well. Okay, hyphen put. If I say some home slash some cloudera slash abc.txt, okay, then space user something like cloudera space Manohar. The first path is from local path. This is I'm trying to keep a file from local machine to HDFS. This is HDFS path. Then what happens? I'm trying to store this data. I'm not trying to process. I'm trying to store it. Got it. There are different ways of storing data. Okay, this is one way. I'm directly trying to keep a file into the HDFS. When I keep a file like that, what happens? That file is split into blocks and it is that is fine. But here, this is storage. But what about this one? I am trying to run a query like this. You might run it on Hive, or you might run a query on HBase. HBase queries are a bit different from like Hive queries. Or you are trying to run some MySQL queries in the Hadoop cluster. Okay, you are trying to run some other queries in the Hadoop cluster. Then it is processing. Okay, and who will come into the picture? When I just try to run this query, first this will go and talk to whom? To the cluster first. Client will talk to cluster, and this has to be executed by job tracker. Who should execute this? Job tracker should execute this because it should assign task trackers on the data blocks wherever this employee details are available. So that employee file information is split across some data nodes. Not that employee details are available in every data node. Okay, it is split and stored in some data nodes. Now job tracker should find that. So what it has to do, it has to ask name node through client. My dear name node, could you please give us give me metadata of these files, which file, EMP file, wherever those blocks are there, it will ask IP address of those data nodes. Okay, and then it will try to start a task tracker in each data node. Okay, sometimes what happens is this task tracker in this data node might be busy. Then what it will do? Then it will start some other task tracker in some other data node which is idle, and these data blocks are moved to that data node. That is also there, folks. Okay, don't think that this task tracker in this data node has to run this. Okay, has to execute on this data node. It's not like that. Okay. That is called data locality. Whatever I am trying to tell you now. What do you call it as the data locality? Listen this word clearly. Sometimes people ask you in interviews. Okay, I'll explain more on this data locality and data compaction in the coming sessions, but still a quick idea. So clear, right? What happens now? When we run this query, first it has to find where these blocks are. Then job tracker will get metadata from name node. Then what job tracker will do? It will start task trackers, and task trackers will execute on all these data blocks parallelly, not just one task tracker. It is trying to start 4 task trackers on this particular employee information. Assume that this is a 4 node cluster. Okay, not 4 node. It will be a 6 node cluster, 7 node. Okay, 3 for master, 4 for data blocks. Then what happens now? Once job tracker gets the metadata, it will initiate these task trackers on the respective data blocks. Then task trackers will execute these data blocks parallelly. Parallelly means all will try to run parallelly simultaneously, and then it will return the result. So that's what it happens here. So what is this task tracker doing here? Who is executing your job here? Is it job tracker or task tracker? Actually, tasks are run by task tracker. It is a slave service or slave machine. What it does? It is used to execute. It is used to execute on required data blocks. Okay, data blocks, and these are initiated by whom? These are initiated by, obviously, who will initiate all this? Initiated by job tracker. Okay, that is one thing. And same like data nodes. How does job tracker know this? All these task trackers are working or not? How does data node? Job tracker know that? How does it know, folks? Any idea? Same heartbeat concept here also. What concept? Same heartbeat concept. Okay, somebody is asking me to share video. Yes, I will share it to you. This thing, okay. We'll talk about all this in the end of the discussion. Okay, I'm talking something, right? How does job tracker know that these task trackers are working? Okay, it will come to know that through heartbeat, same concept. So job trackers communicate with the task tracker communicate with job tracker. How? Through heartbeats. Okay, through heartbeats. I'm just adding this. It's a signal, guys. Don't think heartbeat means it is something else. Somebody is asking yesterday as well. I'm again clarifying you. Heartbeats are signals where this task trackers continuously keep sending the signals to update the status, their availability status, that they are alive, they are healthy, and they are working. Just to update this to the job trackers, these task trackers will be sending signals. Job tracker sends a heartbeat, same thing what we have discussed, heartbeat signals for every 3 seconds, same like name node, 3 seconds. Okay, and update the alive status of task trackers to job tracker. Live status of TT to home JT, job tracker. Okay, I think this is clear, right? Suppose if a task tracker is not sending signal for at least for some time, after 3 seconds, they miss the signals. It will see for some time, for at least for 9 seconds or something, and or for some more time, and assumes the job tracker assumes this task tracker is down, and then what happens? Then automatically, what this job tracker will do? If task tracker is not periodically sending the signals, heartbeat signals to job tracker, then what happens? Then job tracker assumes that a particular task tracker is down, and it will reassign the work of that task tracker to other task trackers which were idle in the cluster. Understood or not now? So suppose if the first task tracker is down, then it will assign to some other fourth task tracker or fifth task tracker. Here we have only 4 nodes. Suppose I am just telling you to assume. Okay. So what it will do? That is what fault tolerance is for us. That is what high availability is. Even though a particular data node is down, a particular task tracker is down, still what Hadoop cluster will do, there is nothing to worry. It will immediately assign that work to other existing task trackers or other existing data nodes. If it is task tracker, the task or the execution of that particular work is assigned to other task trackers. If it is data node, the blocks are assigned to other data nodes. Got clarity here, right? So that's how it works, folks. And that is what fault tolerance is. So if any task tracker is not sending signals, what happens? Is not sending heartbeat signals. Then what happens here? Further. Then job tracker assumes that task tracker is down and assigns the work of the task tracker to, I'm just explaining in normal terminology, task tracker to other available, I'm saying here, if you see available task tracker, because not all task trackers are free. Other task trackers, the immediate one might be busy with the executing the blocks on the respective data node, okay, or some other data node as well. So it will check for the available task tracker and assigns to that. Okay, and what this is telling us, what this say here means it is highly fault tolerant. Even though a task tracker is down, we don't need to worry about anything here. Immediately that is replaced with another task, so that nowhere your work is getting disturbed here. Got it, right? So finally, suppose if a job tracker is down, this is Hadoop 1x again. I am talking about which version? Hadoop 1.x. If you see, I put it as a 1.x here. We are talking about which one? Hadoop 1x. Okay. Now see this. This is what we are talking here. So here in a Hadoop 1x, we have all masters are single point of failure. Is it that? These are single point of failure here. What failure? These are single point of, means if a job tracker is down, then the whole execution stops. You got clarity, right? If a job tracker is down, okay, what happens now? The whole execution stops. If the job tracker is down, the whole execution is down. All task trackers are down. The whole execution is down. Okay. Following that means here all the master machines. What are those master machines? Your name node, your job tracker, and your secondary name. All these are what are single point of failure. Single point of failure. And secondary name node is a not standby for name node. It is not a substitute. You don't need to think that suppose if name node is down, then secondary name node is going to take care of it. Okay? All these are single point of failures. Okay, means if these were down, the whole cluster is down. If name node is down, the whole data is down. It's gone. You cannot have access to any data. Even if secondary name node is down, the housekeeping operations are kept aside. They are stopped. If job tracker is down, then the processing is stopped. So in this way, these are all single point of failures. Means once they are down, then the respective processing or storage automatically is stopped. Got it, right? Then you can ask me, then this is a challenging issue, right? That is why in Hadoop 2x, we have a standby for name node. Got it, right? And we don't have job tracker and task tracker in Hadoop 2x. So in that way, what happens? There is a better mechanism of handling the operations in Hadoop 2x. In Hadoop 3x, it is much more advanced to 2x. We'll see the differences. Okay. Following, right? So now, finally, I have to talk about secondary name node. What secondary name node does? Okay. So generally, this secondary name node is used to perform what? As I had discussed, it is used to perform housekeeping operations. What operations? Housekeeping. What do you mean by housekeeping? I just want to explain this clearly from the official one so that it's clear for you to understand. I think somewhere that detailing is missed in this. Okay, no problem, not an issue. We can go to the official document. We can just quickly get some idea. Okay, fine. So usually it performs housekeeping. What do you mean by housekeeping? It's simple, guys. Housekeeping in sense, whenever you start doing some storage or you start doing some kind of processing. Okay. this metadata keeps on updating. So what happens? The metadata keeps on updating. Over a period of time, what happens here? The size of metadata grows so much that the metadata file grows so big that it is difficult to manage that files. Okay, so that is where this secondary name node comes into the picture. I'll just quickly show you what exactly it does here. Secondary name node in Hadoop. See, you can see this now. Quickly, you can get some idea here. Just we don't need to go too much into the too much of details here. Just a brief idea here. What is that? Secondary name node is a specially dedicated node in HDFS. What it does, which performs checkpointing operation. The exact word is it performs. Even this guy who copies from the official website only. Don't worry. It is a specially dedicated node in HDFS cluster. And what is the responsibility of this? Whose main function is to take checkpoints of file system metadata. Just now I told you, right? Whatever the metadata that is present in name node, it will just do the checkpointing to that. Do you have idea about checkpoints? Even you do that in Windows. You put a checkpoint for your Windows. Suppose suddenly there is some problem, you go to that previous version and you try to install. You remember, right? In Windows, if you add a checkpoint, all that gets getting this, all this will be restored in Windows. Suppose your current this thing is corrupted, you go to the previous version and you try to restore it. Got it, right? That's what this checkpointing is all about. So what this does now, secondary name node, here it's a simple thing. The purpose of secondary name node is just to perform checkpointing of a file system metadata present in name node. And this is not a backup node, as I told you. It is not a backup. Backup in sense, if name node is down, then then it has to take it. But secondary name node doesn't do that. Got it, right? And what it does, it just checkpoints name node files system namespace. Means in a way, what is that? It is used to copy the files of metadata from name node to secondary name node, and it will frequently keep updating these files and performing what is that? That checkpointing operation. What is checkpointing here? So over a period of time, as I was just telling, this the size of these files will become so big that when you restart name node, it will take very longer time to apply all the updates to the name node. That is why what your secondary name node will do, it will frequently move this. It will keep that size of this metadata files in control. Got the point, right? What it will do, it will keep the size of metadata files in control. I think you let it take some time. We'll go for official document. It's good to understand from there. This is official, okay? And now secondary name node. Go to secondary name node here, because that will be cleared here itself. Otherwise, what happens is these people will explain something and they miss something. Okay. Now you see here, what is that? The name node stores modifications to the file system as a log. Actually, this is called FS images and edit files. You can see that even in your Cloudera distribution also. So what is that? Metadata file names are called. They are called as FS file system images. Okay. So whenever you keep adding some files or blocks, the name node keep on changing that metadata file system as a log, and these are added as a log, that metadata appended to the native file system and that is called FS image and edits. And when a name node starts up, I am not going to explain all this everything here. Just we are talking only the first paragraph so that you get a clear, perfect picture about secondary node. When a name node starts up, what it does, it reads the HDFS state from the image file. Just now I told you, FS image. This is where your metadata is available. What when you restart name node, what happens? It will read all the metadata from this FS image whenever if it is required, and then all the updates that happen till that point that are applied to the cluster. Name node will apply those to the cluster, and then what it will do, and then it applies edits from the edit log file. Got it right? Whatever changes you made that are applied to the cluster. These are, see, FS image is a permanent file. If you get confused, I am explaining clearly. This is a permanent file, FS image. Okay. And edit is a temporary file. Okay. Means whatever the temporary changes happening, frequent changes that are updated in the edit file. And finally, once in a while, once, not periodically, once in a file, what happens is all that edits, all that changes happened on this cluster, that storage thing is stored into this FS image. So that what happens, the processing becomes easy for name node here. Now I'll just quickly explain here. You can see here what is the responsibility of a secondary name node. So if you see here, what name node will do, it has two files here, FS image and edit. See, I'm trying to make it so clear so that next time there should not be confusion to you. These are, after this, I don't think I am not going to talk this much about these fundamental basics, because I know how it is when you are not clear with things in the beginning stages. That's why I'm trying to emphasize you have, just carefully understand. Okay, I will explain clearly. So what name node has, there are two files here, FS image and edit files, edit log files. You can see that in the Cloudera distribution as well. Okay, so I can show you that also, these files also. So what happens, this edit log files keep on getting updated. These are temporary files. Once in a while, all these changes which happens over a period of time has to be moved to FS image. Got it right? And then what happens? Then again, name node has to, it performs other operations as well, not just only this. It then writes the new HDFS state to the FS image and starts normal operation with an empty edit file. So after moving these edit files, I told you right, that these are temporary files. It will once in a while it will move to FS image. Once you move all the edits happening in that edit log file, then this edit log file will be cleared. It will be emptied. Again, a new file. No, it looks like a new file. All that is removed from edits, and that's what name node keep doing. It then writes HDFS states to the FS image and starts normal operation with an empty edits files. Just now I told you what happens once all the changes temporarily happen in edit logs. Okay, that is moved to FS image. This becomes empty now. Now since name node merges FS image and edit files only during startup, can you see this point here? Observe this carefully. When can name node can do this? It might be if you have a doubt, sir. You are saying something is there in edit log files. What is there? Edit log also has a metadata. Metadata means suppose you add a file to a cluster, some new blocks are created. That blocks information is updated into edit log file first. Okay, suppose you have added a new data node to the cluster. The IP address of that is available in edit log file. Suppose you have added a new rack to the cluster, that update is available in edit log file. All those updates, what happens? First are stored in edit log, then it has to be updated, moved to FS image. But this change is frequently happening in the cluster because files keep on coming, blocks keep on storing, and this edit log file keep on updating. And when name node can merge these changes of edit log to FS image, only it can do at the time of startup. When you start name node, that too for some reasons, then these changes of edit log are applied to FS image. But by the time what happens, the size of this edit log will be keep growing so much that what happens you see here now. So what happens? This change happens only at the time of startup. The edit log file could not get a very large over, could get, not could not, sorry. It becomes very large over a time on a busy cluster. Then by the time the size of edit log will become so big, another side effect or of a larger edit file is that the next restart of name node takes longer. When the size of edit log becomes so big, then moving all that updates from the metadata from edit log to FS image is going to take so much of time for name node, and that is where secondary name node comes into the picture. Now, instead of name node doing this merging of metadata from edit log files to FS image, secondary name node merges the FS image and the edit log files periodically. It won't wait until this name node does this. The secondary name node frequently whatever data that is coming into edit logs are copied to FS image. That is what the responsibility of a name node, so that the size of edit log is within the limit, so that name node doesn't have any issue at the time of next startup. Got it right? And keeps the edit log size within a limit. Understood now? So what is the advantage? If it is within a limit, then it doesn't, the name node doesn't take much time to merge the changes that were there from edit log to FS image. Got it right? And usually secondary name node run on a different machine. It doesn't run on the same machine as name node. Both are two different servers. This is enough for us. Don't go too much into this discussion. We already have spent more than enough time on this, sir. What is this, sir? What is this check? This is called checkpointing. Checkpointing means moving this data from edit log file to FS image periodically. Is nothing but what we call this as a checkpointing operation. Do you understand this, folks? Are you guys there? Is it clear for
Yes,
all of
Manohar,
you?
it's very clear.
Yes.
So that's what secondary name node does. Because why I took this much time to explain this is many people have a confusion on this when they talk about checkpointing. Many people don't have a clear idea about FS image or edit logs. So they get confused with all this discussion. Got it right? But now, after going to the official doc and clearly understanding that, what you got a clear picture? What is the responsibility of secondary name node? It is, the purpose is housekeeping. That housekeeping is also called checkpointing. What checkpointing does? It will periodically update all the metadata that is stored in edit log to FS image file. That is what the responsibility of secondary name node. This can be done by name node, but the point is it happens only at the startup of a restart of a name node. By the time the edit log file will be grown so much big, because in a real-time cluster, many things happening in 1 minute time or in 1 hour time or in 1 day time. It's not like our normal Cloudera distribution, which we do practice. And hundreds of people, or at least some tens of people working on cluster, so that they keep on adding files. They keep on, then metadata keeps on growing. When you add file, that file information, that file name, that file blocks, okay, all this has to be updated as a metadata in the name node metadata. Then the size of that edit logs keep growing. So to keep that in control, so that name node doesn't have any problem at the next restart, to apply those changes from edit log to FS image, the secondary name node takes care of this checkpointing, where the merging of these edits to FS image periodically happens for every 1 hour, for every 2 hours. That can be set by the administrator. But as a developer, this is more than enough for us. You again, I'm bringing you this point. We never notice all these things when you are working as a developer, big data developer. You don't see secondary name node, you don't see name node, you don't see, of course, nowadays you don't have job tracker or task tracker, even you don't see what yarn is doing. Unless until you are very curious about something like, okay. Otherwise, there is nothing like you don't see all this. Got it right? Why then? Again, I tell you right. In the beginning, when you are learning a course, getting this detailing is very important. Understood? So for now, what is this? we have completely discussed this. All this. This is Hadoop architecture. HDFS. Sorry, this is HDFS architecture. Got clarity now? So now you got clarity about name node. You got clarity about secondary name node, job tracker, task tracker, data node. All this is clear now. All of you are good now. Okay.
Yes.
Yeah.
Yes.
So with this, we have completely understood what is that. We completely got a clear idea about what?
Hadoop HDFS architecture.
About HDFS architecture. Okay.
This architecture.
Yes, yes. Yes, sir. So I'm getting some music. So please, what do you do? Yeah, thank you. Secondary name node. Finally, what it does? It performs checkpointing. What is checkpointing? Periodically moving, okay, or periodically updating data metadata from edit logs to FS image. Okay, updating metadata from edit log. We can see all this in the cluster. Okay, edit log files to FS image. FS is permanent. Edit log is temporary. Files is called what? Checkpoint. And also this is called as housekeeping as well. Okay, so this is for this point is enough for us. Now, what shall we do then? Now we got a clear picture now. So finally, let's quickly conclude HDFS architecture. How many daemons are there in Hadoop 1x? Daemons means thread. Thread means
5.
process. Process means service. 5. What are those 5? One is a
Name node, data node, job tracker, task tracker, secondary node, name node.
yeah. I think you just woke up, dear friend. What is your good name? I see that.
Yogesh, I was
Yeah,
like sleeping and seeing.
fine. Let's continue here. Secondary name. So these are daemons. Now you quickly tell me now because you have clearly understood, right? What name node does? Okay, just give me in the chat box. No need of what is that? Just
Holds metadata.
yes, exactly. It monitors what? I'm just concluding. I'm not again explaining. Monitors data nodes and also holds what? Metadata. That is one thing. What about is it single? I'll quickly ask you questions. Answer this in the chat box. Is it a master or a slave?
It's a master.
Master.
Okay. Is it single point of failure or do we have any standby for this?
Single.
To failure.
Is it you can answer in the chart, okay? Because if many people try to answer, this becomes again a fish market. So what I suggest is keep answering in the chat. One or two people answer it is fine. If it is it single point of failure or do we have a standby for name node in Hadoop 1x? Again, we are talking still about 1x version.
Single
Okay,
point of failure.
single point of failure. Exactly. Now, data node. What do we have in data node? Where this data exactly stored? Is it stored in data node or name node?
Data node.
So, how this data is stored in Hadoop cluster? Is it stored? A file is stored as a file itself, or is it stored in the form of blocks? How it is stored?
Blocks.
What is the size of each block? What is the usual size of each block?
128 MB.
64 MB or 128.
128
Usually,
MB.
nowadays it is 128. Okay. Keep answering. Okay, so that it's good for us to recollect. Now I am not again explaining because I have explained enough. If I explain one more time, then you will run away from this session. I know that. So then what else? Suppose if a data node is down, Do we have any standby for that? Any substitute for that, or that's it? That is the
No,
final.
it will substitute. That blocks will move to another available data nodes.
Very good, very good. Then what about secondary name node? Why do we need secondary name node? Is it a standby or is it something performing some other operation?
No, it's
What is
a checkpoint. It's doing the checkpoint.
it? Performs housekeeping operations.
Yes.
Okay. So it is not a substitute for name node or a standby for name node. Okay. Then housekeeping. This is a bit, you have to answer this because I have spent so much of time on that. What is housekeeping? Move
It is
periodically moving the
updating the edit
uh,
log file to FS
FS
images
image.
file.
What is the advantage there? What is the
When we
advantage?
restart our
Hmm. So that the edit log file will be under control. The size of that edit log file
the
will be
size of
under.
yeah.
Do you understand that? Okay. Then what
Yes.
job tracker does? So now whatever we have discussed, name node, data node, secondary name node, they are handling what kind of operation? They take care of storage. Now what about job tracker and task tracker? They are doing what?
Processing and analyzing.
Processing. Okay. So what is job tracker here? It is a master node. It is a master service
Yeah.
which monitors all the, or which monitors who? All the task.
Task trackers.
Is job tracker single point of failure or does it have any substitute? Keep answering,
It is
folks.
also single point of failure. Yeah.
Okay. Is task tracker single? What is task tracker now again? What it does?
The task executes. It will execute the
It
task.
executes the tasks. Tasks where this task tracker executes this tasks on blocks
Data
available in.
nodes. Yeah,
Okay.
data nodes.
Okay. Is it single point of failure or does it have a substitute?
It will has the substitutes.
Okay, it has a
I have one
substitute.
doubt.
Yes, please. 1 minute. Let me finish this, then I'll come to your doubts. Okay. Let me finish conclusion. Somebody, I don't know your name. Sorry.
Yeah,
I'm almost done. I am almost done. Then we can have discussions. Is it single point of failure or it has a substitute? Somebody is saying Bharat, right? Bharat is answering. I hope.
It's
Right.
Suresh.
Yeah, Suresh. Sorry. I'm really sorry.
Yeah.
This is all of you are good now. Can you tell me, are you good with this?
Yes.
Okay, I think it's enough. No, this discussion. Now you can ask questions. I'm asking me some question. Please, you can ask.
that secondary name node, so taking backup, I mean, so from that edit logs, FS image merge into the, so secondary name node. So if
Yes.
not the name node, primary name node down, then somewhere I read it, so we can take backup from the secondary name node after recovering of primary name node, and then we can restart it again. So
Okay.
in that case also it helps, right?
That is a good point. Point is, see, the purpose of secondary name node is just to have that edit log file in control. And one more thing is, when you say that secondary name node has this file information, no doubt about that. Which files information? This edit logs and FS image, and till the point. Got it right, Madhu?
Yeah.
Once name node is down, the problem is the entire cluster is down. Of course, as you say that backup information is available with the secondary name node, but secondary name node cannot monitor data nodes, or it cannot hold this metadata completely. The actual metadata is available with whom? It is available with the name node only. Do you understand that?
Yeah.
And second thing is secondary name node, of course, apart from housekeeping, it doesn't have any other responsibilities, but monitoring data nodes and giving updates to other, suppose job tracker needs to execute some task. So then it is going to ask name node or secondary name node for metadata? Whom it is going to ask?
It will ask for name node only, primary name node.
Exactly. So if name node is down, is there any way for job tracker to get metadata?
No. It won't. There is no any way. So always the primary node only will act as, so that to store that metadata and so give response to so job tracker. But
Yes.
I read it. So after down, we need to
Yes.
bring the primary name node into alive. Then we need to copy all the data from the secondary name node, and then we keep running.
That should be
So
correct.
in that case
That
also,
should be
secondary name node will help to take the backup, and again a cluster will be alive.
correct. See, that point should be correct, because as name node is down, as the machine itself is down, then what do? You go where? You get that might be there is a possibility to go to because it runs on a different server. This file details were there in secondary name node. So they try to get that from secondary name node and apply it where? For the name node. That might happen. But overall, what I'm trying to tell is, what is that? Apart from that, okay, that is a good point to add, Madhu. Apart from that, remaining other things. What else?
Yeah, housekeeping.
Remaining other things, controlling data nodes, or having that other services, extracting metadata. All this happens with the who is the POC for all this point of contact? Name node becomes the POC. Understood? Of course, when name node is down, to get that FS image details, obviously secondary name node will help us. That should be sure. That is a good point to add here as well. Okay, clear, right?
Yeah, so that will come in picture when if FS image get corrupted in name node and it is not able to come up, that time we can restore that FS image from secondary node and we bring up, but still we will lose the 1 hour of data because checkpointing is happening every 1 hour or
That's what
1 million record. Yeah.
correct. I told you a point here also. Till the time name node is down, you can have update from where? Secondary name node. And also, yes, you also update a checkpoint there. Periodically, you are updating secondary name node. You put some time limit. For every 1 hour, you take backup. For every 2 hours, you take backup. Then, who's that updating this point? Can I have your name?
Yogesh here.
Yeah, Yogesh, that is the correct point to add. Again, that 1 hour data you might add, because before 1 hour name node is down. Then there is possibility of losing that 1 hour update. That is also there. But there is nothing to do on this, Yogesh. If we are losing that, there is nothing. You have to again restart it and start from the previous thing
Yeah.
only.
Yes, correct.
Okay, there is but still all these are mostly hypothetical. 99% these are hypothetical. It doesn't happen mostly in real time. There will be other way of storing all these things. Okay, nothing to worry about it. Don't worry. You can get more information from administrators. Clear, right? That's
Manohar,
all about. What is that?
Kader Basha here.
Yeah, Kader, please.
Yeah, in case name node failure, so you told like secondary name node will be a backup for name node, right? So how the data will be, for example, name node will be updated metadata for checkpointing happen, FS image and edit log. Okay. So how come secondary name node will be having the same data? What is the communication between name node and secondary name node?
What is the communication between name node and
Secondary name node.
because that's what, right? Secondary name node purpose is that only, right? It is on behalf of name node, it is periodically updating edit log files to FS image. Means the job of what name node has to be done, some part of that managing this edit log is deviated to secondary name node. That is the connection there. And obviously internally they will be communicating.
No, who
Obviously,
will intimate to secondary name node whether name node is failure or not?
who is that?
Who will intimate to secondary name node? I mean,
Nobody
how
intimates,
secondary?
but that nobody intimates. Administrator know that this data is available in secondary name node. He will I think he will try to get that from secondary name node and try to apply that changes to name node. That should happen somewhere. But see, I am not that too much into the administration. Whatever that is necessary to understand architecture, I have explained that. Okay. For more details, what you can do, you can check with any administrator in your company, or you can try to get some googling. Got it right? If I am an
Yeah,
admin,
yeah,
I
okay.
can go too deeper into this discussion. Got it? Next one. So that's all, guys. Now let's see the limitations of 1x. So whatever that is necessary to understand to be a developer, you try to get the details, okay? And more information on this, admin related things, you can try to get, because you are working professionals. You can check with your admins in your office, Hadoop admins, because most of your working people are. If you Google, I don't think you get too many of these details. I know very well. The best choice is try to talk to your administrators, but that is only necessary if you want to step into the Hadoop administration. For a developer, this is more than enough. As I told you, when you work in a real environment, you don't see all this. Okay. So then what are the limitations of Hadoop 1.x? Here there are a couple of things. First thing, you know very well, there is a single point of failure for name node, as well as what is that secondary name node, as well as job tracker. This is one of the biggest limitation. Again, I am telling you, all this happens very rarely. There is a possibility, I don't say that, but it happens very rare. But still, admins will take care of some kind of preventive measures not to lose or anything out of this. Okay, don't worry about that part. Then second one, other disadvantage here is job tracker is fully overloaded. So what do you mean by that? Because job tracker has to take care of both resource management, like so this is one important point you need to update here, get updated. Means there are two more things happening from a job tracker side, apart from what, apart from monitoring all the job trackers, apart from what is that getting more information, uh, trying to execute the tasks. This will also performs two things. One is resource management and scheduling. Observe these points carefully, because when we start 2x, Hadoop 2x tomorrow, I don't take much time on this again. So here in the 1x, this is the greatest disadvantage, as it is taking care of both resource management, means allocation of when a task has to be executed. So if you look at this diagram, I'll just show you. If you see, this is a task tracker, right? If this service has to run, for this task tracker, your job tracker has to allocate resources on this node here to execute these blocks on this data node, and it has to allocate the resources. What are those resources here? Resources in sense, job tracker has to allocate a RAM, a CPU, a disk, and a network for this task trackers. Then that will become one virtual machine. It acts as a virtual. All these are virtual machines. Again, this acts as one virtual machine, and what it does, that will execute the data on the data nodes, and also it will also take care of scheduling. Okay, scheduling means what, which task tracker has to execute on which nodes. Okay, all this is done by the job tracker itself, and because of this, what happens is this job tracker becomes overloaded in sense, it becomes performance wise, it is going to get down, as it is taking off all these things. That is where again in Hadoop 2x, this is replaced with the yarn, and these responsibilities are split actually in Hadoop 2x. Got it right? So that is one more important. Next one. And as per update, the maximum number of nodes in this cluster Hadoop 1x will be up to 4,000. Suppose if you go to Hadoop 2x or 3x, it can be about 10,000 nodes in the cluster. And also, you don't have no horizontal scalability of name nodes. Of course, you can have a single name node, You cannot add other name nodes, additional name nodes to the cluster. You know what is horizontal scalability? I told you this point. If you can add more nodes to the cluster, then that kind of scalability, you call it as horizontal scalability. You can add new machines to the cluster. Okay. So the point is, for name node, you don't have such thing. Even for job tracker, you don't have horizontal scalability. Even for secondary name node, you don't have that. Okay. So next one. These are all single point of failures. So that is the one. Next one. Another important thing. What is that? It supports only one processing model. Here in 1x, only map reduce is available for us. Which is available only map reduce. We don't have any other. But if you go to 2x, you have Spark, you have Tej, you have so many other processing engines. But the only processing engine which is available in Hadoop 1x is what? Map reduce. That's all. And this is only targeted for batch processing. Okay, what do you mean by batch processing here? It is just to process periodical data. Whenever you say batch processing, already existing data that is accumulated over a period of time for some years, to process such kind of data, Hadoop 1x is used. Suppose if you go to Hadoop 2x again, you can process live data, streaming data as well. That is also possible with the Hadoop 2x, but that is not possible with the Hadoop 1x. And again, you can see here, no support for streaming data here. You don't have a support for streaming data. That is also there. This is only applicable only for batch data. Next one. And one more important disadvantage is it has a fixed map and reduce slots. Because you are running a map reduce, you understand this point better when we start discussing. When I briefly explain map reduce topic to you, you have, whenever you try to run some process, you need to have map slots as well as reduce slots. Okay, then this will be handling the processing responsibilities. And once Hadoop allocated RAM, CPU, disk, and network for mapper or reducer, then they cannot be used by so that resources. Actually, what the point is, suppose resources are allocated for mapper and reducers. Okay, these are used to perform processing. Mapper is a program and reducer is a program. Both performs two different types of operations. Mapper performs some mapping operation and reduce performs some reduction. What is that? I'll explain in map reduce topic. You don't need to understand. You don't need to worry about that at this point. Just get an idea. When you have map reduce slots, for that slots, memory has to be, all this has to, resources has to be allocated. And once these resources are allocated, suppose a particular map and reduce slots are free, but still, what is that? These, once they are allocated, even though they are not utilized and they cannot be used by other mappers or other reducers who are busy. And if they want those resources, if they want more resources, still we cannot assign these resources allocated for this map and reduce to other mappers and reducers. So this is the disadvantage. Means there is a wastage of resources here. In a conclusion point, we have wastage of resources with this 1.x here. Okay. And finally, what is that? Multi-tenancy. It doesn't support multi-tenancy. What is multi-tenancy? I'll just update you quickly. I am not sure about this. We'll see in the tomorrow session. Okay. That's all, guys. This is the idea about limitations here. Finally, point is, you can, from the discussion, we can easily understand many things. There is a single, you don't have support for single point of failure. All these name node job trackers are single point of failures. What else? It supports batch processing. It doesn't support streams. What else we have discussed? And also the scalability factor. It has maximum up to 4,000 nodes. That is also one more disadvantage. Okay, that's all. And job tracker is fully overloaded here. It takes care of both responsibilities, resource management as well as the scheduling. All this were there. Okay, that's it. Multi-tenancy, I will update tomorrow. I don't exactly remember this. So tomorrow we'll see Hadoop 2x and see the differences between 1x, 2x, and I will explain how to install that Cloudera distribution in your local machine. Those who wish to work with that, you can work with that. Mostly, I will also be working with that only from my local machine. Once in a while, I will also keep in touch with that CloudX lab. Okay. Clear now? See,
Yes, Manohar.
this administration related things, I cannot go that deeper into these discussions because no, I am a developer, I am not an administrator. So suppose you can see my experience when we start talking about programming part, like if you talk about Scala, if you talk Spark, if you talk about HBase or Hive, you can see all that there. But at this level, whatever that is necessary to understand for a developer, that information we can get all the details. Okay.
Okay,
Any more
Manohar.
questions? Any more questions?
Yeah, thank you, Manohar. It was very informative. So, you're giving a more, like elaborated way of, understanding this. So, really, I appreciate that, and it'll be very helpful. So,
Who is
that's my
that?
point of view.
What is your
My name
name?
is Suresh. My name is
Oh,
Suresh.
Suresh. Yeah, thank you,
Yeah,
Suresh.
actually, I'll directly some administration